That's what it takes. That's what it takes. All right, guys, so everybody's got a practice test now, right? I've got the answer key. Should I give out later? Some of you guys got the special one with this lifeline on it. Oh, well, you can read tests like you can read palms, but it's got a long lifeline. So today is really up to you what you want to focus on. Yes? Is that the... Which one? Number 4? This one? Oh! Alright, sorry. This was, as I was discussing this yesterday. That was an example. Because somebody was saying, what was different between these two is not just that there's missing coefficients. It's that these I can do something with. So maybe I can make them like terms. These are not like terms, and I can't do anything with them, so it's already simplified. Yeah. Yeah. So that wasn't an answer I put below that. That was we were discussing something, and I wrote that as an example. Cool. Okay. So, is there a topic you guys want to focus on? Do you wish this test was over? Yes.
Could you like 1 3 for the practice test?
Okay. So, of course, a cube root cuts everything up into thirds. Multiplicatively, right? So what is the cube root of 27?
3.
Why? Because 3 times 3 times 3, it takes 3 threes to make 27, and the cube root cuts it into thirds. So it takes one of those. That's why a 1/3 power makes beautiful sense. It's 1/3 of what makes 27. Well, 3 threes make 27. One of those is 3. Done. Right? I'm not totally done with the problem yet, but I'm done with the cube root 27. Now, the reason that exponents act different is because they are different. Right? Now watch. I want to show you what I mean. That's normally a good idea, Jeff. Show them what you mean. So what we just did was this. And this kind of acts differently. But not really. They can't. If I wrote, what is 27 is what to what power? 3 to the power 3. So how do I do this? How do I do this one? 3 goes into 6 twice. Why does that make sense? Because I'm cutting it into 3 parts. X6 would be x squared, x squared, x squared, because it takes 3 2's to make 6 total. If I write a number with a power, it's going to act the same way. 3 goes into 3. 3 goes into 3. Once. So the answer is 3 to the first. Yes?
Or you can convert it to x to the 6 thirds.
Yes, exactly. I love it. Which is really just showing more directly.
That makes it easier to understand.
I like it. Okay. Hopefully that makes sense. So again, what is the 4th root of 16? 2. Because 16 is 2 to the 4th. 4 goes into 4 once. So that's why the answer is 2. I want you to, if I write it in exponential form, it will act as exponential form things do. So 27 is not written in exponential form. That's why it doesn't act the same way. I don't do 3 into 27. That's not what that means. Now we just did this one. That'd be x squared, and of course y to the cube. I like that. I like it. Yes, ma'am.
What about 2C?
What's up? 2C?
No, wait, never mind. I was looking at 1C.
I'm sorry?
I was looking at 1C now.
I actually, I thought that was a challenge. So guys, does anything times itself 3 times make 32? Yes, but is it a nice number? No. My God. It's going to be a little bit more than what? Somebody could do that for me? What's right below 32 that it can do the cube root of? 27. So the answer would be 3 point something. So it would be a little bit bigger than 3 because the inside is a little bit bigger than 27. And the answer would have been 3 if it would have been 27. Does that estimation idea make sense? No? Okay, well, that's not really what I'm asking here, but I'd like you to realize what's going on. There is an answer to this problem. There is a number answer. It's just never ends. It's a decimal that never ends. So we're not going to do that. I'm going to instead keep it in radical form, but try to simplify what I have. What part of 32 can I do the cube root of? If I break 32 up. Why would it not make any sense to make it 16 times 2? Because 32 is 16 times 2, right? But why does that not make any sense? I can't do the cube root of 16 or 2. What can I do the cube root of? 8. Isn't 32 8 times 4? And what's the cube root of 8? 2. And what's the cube root of 4? I don't flip it now. Yay. I like it. You like it? Yes? Oh yeah, this one's beautiful. This one's gross. What I do on this one, do you notice how it's all a single line? Do you see what I mean by that? So I'm not going to flip anything. I'm just going to distribute that negative 2/3 power. And then I can look at it as 3 separate problems. Because what do I do when I have a power sitting on top of something? I distribute it. If it's all multiplication on the inside, I'm allowed to do that. Why am I allowed to distribute that? Because exponents are based on multiplication. So of course it's going to play well with multiplication. So what do I get? 8 to the negative 2/3. Nobody in the world said you had to be able to do all that shit in your head at one step. Where you guys mess yourselves up. I think you're supposed to be able to. Why the shit do that? Then here I get x to the 2/5 times negative 2/3. And here I get y to the negative 3 times negative 2/3. Hopefully you guys remember that. When you raise something with a power to a power, you multiply the powers. No need for an LCD. My God, right? And now you just clean all of those up. How do I do 8 to the negative 2/3? How the hell do I do that? The negative power means flip it. And what's the 3 mean? Cube root. Good. So that's how I can take care of that piece. What do I get here? X to the what? Negative 4 over 15. You guys with me? A little bit? I love you guys. You're all freaking me out. You're all looking this way, but when I ask you questions, nothing happens. Okay, sorry. I had to be you for a minute. And then here, what do I get for a y piece? The negatives.
6 over 3.
Well, even better. The negatives cancel and 3's cancel, so you get y squared. So here I get 2 squared is 4. That's on the bottom, right? This x to the negative 4/15 wants to go down. And what's left on top? Y squared. Bam. Bruce, is that the only steps to take to get there? No. That's the way I do it. There are other ways to do the problem. Yes?
Or didn't you just multiply 8 times negative 2?
Why didn't I?
Yeah.
Because that's not what it's asking me to do. This is, all of this is being what? What is the negative 2/3? It is a, what is the negative 2/3? It's a power. So it's not 8 times negative 2/3, it's 8 to the negative 2/3.
Okay, so you multiply the other one because their power is still.
Yes, I love it. Okay, now watch. Okay, all right. Brianna's like, oh shit, I just opened up a can of soda. So watch this. I really want this to make a to the negative 2/3. Watch this other way you can do this problem. You ready? We already did it. What do we get? 1/4, right? We got 1/4. Is that cool? When we did that? Okay. Anything else I do, I better get 1/4. Or else this other method is shit. Right? What is 8? What to the what power? 2 to the 3rd power. Now that I've written it, I really want this to make sense. Now that I've written it in exponential form, I can attack it like anything with an exponent. What do I do with the powers? Multiply them. What happens to the 3's? And what's 2 to the negative 2? Freaking 1/4, right? Same freaking thing. So if I write numbers with exponents, then they will act the same way as variables. Variables are always written with exponents, because I don't know what the shit they are. I got 6 x's and 8 y's. But if I got 6 2's, I multiply them together, it makes 64. I don't write 2 to the 6. But if I did, it would have to work the same way. You guys really get that? That's one little thing about math that kills me. I don't blame you that much. But that's why I keep saying stuff like, there is no negative 3. There's just 3 y's that I've lost. I mean, it's that kind of thing. It's because it's written in exponential form. So the exponent doesn't mean a number. It means how many of these things I've got. It's a different form. So of course it's going to act differently. All right, maybe. So either way you do it, it should come out to be this. Whew. So this one was a slightly involved problem, but I want you to realize it is 3 separate problems. So if you do each little problem one at a time, you'll be fine. It's the people that try to do the whole thing at once, they worry me. You can't do that. Bless you. Okay. Yes? Okay. Ooh, yummy. What idea do I use here? Multiply by the conjugate. I like it. Not the conjunction. I like it. Conjunction. What is the conjugate of this? What does conjugate mean?
Oh, but it'd be 5 radical 2.
Yeah, 5 radical 2. Minus, that's 7. Another idea for conjugate is difference of squares pair. Right, if I said x minus 2, what's like the difference of squares pair that would go with it? X minus 2? X plus 2. There you go. That's all conjugate is. What happens with difference of squares, when you multiply them out, you get the middle term cancels. That's what I want to have happen here. Does that make sense? Yes?
Can you only do the conjugate when the denominator has 2 things with addition?
When it's got 2 terms, you have to use the conjugate. When it only has 1 term, you don't.
On the denominator?
Yes. Yeah, whichever one you're trying to rationalize.
Do you ever do it on the numerator?
You can if the instruction said rationalize the numerator, but that's a more freaky thing. You have to do that kind of thing in calculus in a few different situations. Or in this book when they ask you to. Yeah. All right, and then here, what would you do? You would just FOIL like crazy, right? On the bottom, you better end up with what kind of number? What kind of number? Rational. Because right now it's completely irrational. When I multiply it by its difference of squares pair, it's going to become totally rational. That's why we call it rationalize the denominator. Now how do I divide is I do this. I rationalize the denominator so I end up with all the radicals on top. Radicals are bad enough. They're even worse when you're dividing by it. That's kind of the idea behind this. So now you just FOIL. Is that cool? Once you see this first step, you should be able to attack this. Let me see if that's true. Looking at your faces and not getting a damn thing. So let's see. Rad 3 times 5 rad 2 would be 5 rad 6. Rad 3 minus rad 7. When you multiply those, you get minus rad 21. Blah, blah, blah. Now, I'm not saying that the blah, blah, blah is unimportant. I'm saying that you better be able to do that shit. I mean, this is the part that should be not too bad. Just FOIL it out. You know how to FOIL it. On the bottom, you FOIL it out, and you should get a rational number. All your radicals should cancel. If they don't, you did something wrong. Again, I've got the answer keys. Don't freak out. You're like, give me the answer. I will in a minute. The most important thing here is to do the right thing. Multiply by the conjugate. The difference of squares kind of idea. Yes?
How did you get to 5 and 6?
Where's it again? Oh, I started to multiply. What's rad 3 times 5 rad 2? 5 rad 6.
Oh.
Do you guys see that? Let me make sure I really get this idea. But you guys, I have to guess at what you do and don't get, because you guys don't like to let me know. So if I have x times, let's say 3x times 2x squared minus x. Right? And you're like, please, Jeff, give me that shit on. No, too bad. You're not going to get this. You should be saying that. Should be really freaking easy. What do I get here? Why didn't you multiply the 3 times the x squared? That's a weird-ass question. Do you guys understand that? I'm like, what do you mean? I did. It's right here. It is multiplying by the x cubed. But what do I combine is the numbers and the variables. The things I can combine, I combine. The other things, I don't because I can't. So on this problem, when I got rad 3 times 5 rad 2 minus rad 7, let's just look at that piece of it. When you multiply these together, what's understood to be out here? 1. 1 times 5 is 5. Rad 3 times rad 2 is rad 6. Minus 1 times 1 is 1. Rad 3 times rad 7 is rad 21. And you keep going. Numbers multiply, radicals multiply, because you can't put them together unless they have the same roots. You can't multiply them unless they have the same roots. Is that cool? I mean, that's really all there is to it. So you just kind of keep going on that problem. Keep on going, keep on trucking, keep on foiling. What other problem could I have to ask for you? I full ask this problem, I give it to you. It's on a, never really hear that term. This problem has been fully done, full ass done. Yes? Which one? 4B? This one's a lot like a 2C, right? Because right now, do I have any like terms right now? No. But don't say can't do or something, because you can do something. You can break up each of these. What's a good number to use for 40? Consider as a cube root? 8. Notice how I see 5 a couple times. Do you guys see that? I keep pointing out how several problems have hints in them. I'm going to try 5 into 135. And you'll get 27, which is a great number to get. Why is that a great number to get? Because it's a cube. Oh my goodness. I still am sick, but I feel so much better than yesterday. My God. I was incoherent yesterday, and some of you guys are like, you're incoherent every day. I said, all right, thanks. So what do you get here? 2. Cube root of 5. Now what do I do with this? What's cube root of 27?
6.
Times 2 is 6. This is all multiplication here, right? So there's no question. What do I do with that? Well, you do what it says. It's multiply. So you multiply this shit. 2 times 3, 6. So I got 2 of these plus 6 of these minus 1 of these. 7 of these. Don't lose the little cube root symbol, because that's like magic. You transmogrify the root. I don't know what this shit. You were a cube root, now you're a square root. No, you can't do that shit. And see, C is the same idea, just with square roots. So you want to use square numbers to break those up. You guys cool with this? Yes? No? Anybody come here yesterday and sit for a while? Because they don't put notes up anymore, I'm sorry. Always check your email. Yes?
Did you do 2I yet?
2I, there it is. No. I mean, I did, but no. What do I do there when I have variables with powers dividing like bases? What do I do with the powers? Subtract. That's it. So you just got to get LCD between those two fractions and subtract it. So it'll be x to the whatever the hell 4/9 minus 5/12 is. And again, what tells you what to do is the process. Processes in math don't change. When I divide things like bases with powers, I subtract the powers. I don't care what the hell the bases are. I don't care what the hell the powers are. That's just the process. Now, when I actually want to do the process as a human, I go, shit, this fraction. I got to get a like denominator. But that doesn't mean the process changed. Does that make sense? It just means the numbers are different. I got to treat them as they are.
He says it's x 1 over 36.
Oh, yeah. Sure. So once you subtract these two, I do think you get 1 over 36. If I remember right, I've got the answer key here somewhere. You guys, so like, what's this? Yeah, there's 5. 7 to the 3m over 7 to the m. Are they like bases? Yes. And it's dividing, so what do? Subtract the powers. So you get 7 to the 2m. I mean, do you guys see that shit? Do you see it? People put 1 there. I don't have 7 divided by 7. I got a whole bunch of 7s divided by less 7s. I got less 7s left. The base doesn't change. I just change how many of the base I got. Using what? Subtraction, because that's what you always do when you divide like bases, always. People are like, oh, they put m's in it, everything changes. No. That's what messes people up in math, is you think, I change one thing and everything changes. Oh, God, no. Shit. You can't. All right, sorry. God. I feel ranty today. Sorry. Probably feel that way a lot. Yes?
Graph part for the question 9.
Ooh, yeah. Well, first off, what's the domain? How do I get the domain of this? No, you don't plug in here. Yeah, you say the inside has to be... So why do we say that? Because the domain relates to what real numbers I'm allowed to use. What would decrease the amount of real numbers they're going to use is any problems the function has. And when will this function have a problem? When the inside is negative. Then we have complex numbers which you do not want to graph. So when I say graph something, it's really inherently meaning over the real numbers. So that's got to be true. So then it can solve for x to see what's got to be true about x in order for that to be true. So subtract 4 divided by 2, I get x has got to be at least negative 2. So why do you think I made you do that first? Is because now when you make an xy table, what's the very first number you're going to put in there? Negative frickin' 2, because that's the smallest it could be. Smallest it could be. So negative 2. Now I'm going to be smart, like I am every now and again. I'm not going to put negative 1 in there, because that would be the square root of 2, which is gross. I'm going to put 0 in there, because that would be what inside? 4. Square root of 4 is 2. When I put in negative 2, I get negative 2 times 2 is negative 4 plus 4 is 0. Square root of 0 is 0. That was a long trick. Yeah. And then let's see, what else can I put in there? 6. I think it's the next good thing. don't know if you guys can see how I see that. And I keep trying x's until I get something that's square rootable. So 6 would be 12 plus 4, 16. Square root of 16 is 4. And then you just got to plot those points. Now, can you right now, in the air, show me what a square root function looks like? Yes, I like it. Whoa, no? Sort of? A few of you guys are playing with me. So like if I said x squared, you go like that for parabola. If I said absolute value, you do a v. Square root looks like this, right? Or from your perspective, that's with me. It looks like half of a parabola that's lost its bottom half. Why did it lose its bottom half? Because it can't be negative. So I know it looks like this. I just need a few points so I can connect them in that shape. So if I know the shape of functions, I need less points. So now I can just plot negative 2, 0, 0, 2, 6, 4 would be way out there, but I got the general shape of it. That's what it generally looks like. Now with B, what's the domain for B? Yeah.
So if the x is less than or equal to, it will be the opposite. The row will be the opposite.
Yeah, it would have been this way.
Yeah.
Yep. What's the domain for this guy?
All the numbers.
All real numbers. Oh shit. So now you just got to keep plugging x's in that come out with nice outputs. What's the cube root of a negative number I can do? Give me a negative number that I can do the cube root of. Negative 8. Which you can use. How do I get a negative 8 inside? I put a negative 6 in. Negative 6 minus 2 is negative 8. You guys see what I'm saying? Look at the function. What numbers can it handle well? And then what do you make x to make that number show up? So I know it can handle negative 8. And inside is x minus 2. So what do you take 2 away from to make negative 8? Negative 6. Hey, that's a good input to use because it leads to an output that's nice. I don't want to try to graph 1.73546, whatever. I can also show that the cube root of negative 8 is negative 2. What's another cube root of a negative number I can do?
1.
Negative 1, I like it. What do I make x so I get negative 1 inside? 1. Cube root of negative 1 is? Negative 1. Negative 1 times negative 1 times negative 1 is negative 1. Hey. And so forth and so on. I like it. And it's got the general shape of this. Why has it got, that is a square root right there, right? That's a square root. And it didn't have a negative because it's not allowed to go negative, but what a cube root's allowed to do, they're allowed to freaking go negative. So, there they go. Shit. It's like a mirror image underneath. Going the other way. Oh, okay, okay. Yes?
Wait, how do you know it's all real numbers?
Say again?
How do you know it's all real numbers?
Why was this one not all real numbers? Primarily because it's a even root. Odd roots have no problems. I think I was a little evil. Where was I evil? Ah, yeah. I love this problem here. Does the root have a problem? This question is find a domain, right? Does the root have a problem somewhere? It's an odd root. No problem. Does that mean it's all real numbers? No. Because where does the inside function have a problem? Yeah, what can the bottom not be? 0. So that means x can't be 6. Because that makes the bottom 0. X could be 0 all freaking day because then the bottom's negative 6. Who cares? So x can't be 6. So that domain wasn't all real numbers, not because of the root, but because the inside function had a problem. Right? So how do you determine domain when you look for all your problem spots? Who's got a problem? Who's got a problem? You got a problem? Shit. Throw that shit out. Yes? Whoa. So the other phrase I used for rationalize the denominator was complete the root. I like that. It's quicker to say for one thing, but what does that root require? How many things inside? Does that root on 8a, how many things does it require? A cube root means how many things? 3. And how many things does it have right now inside of it? 1. It's got 1 2. I like it. It's got 2 1s, but adding that's no good for us. It's got a 2. So how many more 2s does it need? 2 more. And how do you do this legally? How do you give the bottom something? You have to also give the top the same thing. So you multiply by cube root of 2 squared. Top and bottom. Because now on the bottom you're going to have 3 2s. And then you can do the cube root of that. So if it was a 5th root, I would have multiplied by 2 to the 4th, because then that would end up with 5 things. It's that simple. If you look at the root, you see that's how many of each thing I need. And then how many more do I need to make them up to that much? That's really the question. Sorry. Yeah, what do you got on the top? 3 times 4. I'll do that one for you, 12. It's a little early. On the bottom, what am I going to get? I'm going to get 2. I'm going to get the cube root of 8, which is 2. Bam. Is the denominator rational now? Yes, so I rationalize the denominator. The bottom is rational, right? 2 is rational. Square root of 2, or cube root of 2, is irrational. No good. Okay. Let me give you guys the answer key. You got a few minutes to look it over and make sure I did it right.
That's just interesting. Yeah.
Oh. Oh yeah, I told one lab this and I forgot to tell the rest of you. I can't remember if I said this in the email. 6D, E, and F are going to be on the next test. I just forgot to take those out. I had to Frankenstein my test together from previous 110 tests, and I just forgot to delete those. That's why in the answer key 6D, E, and F are just crossed through. So if you did those, congratulations. You're ready for part of the next test. Huzzah! Uh-oh. 7, which one? 7A? B, C, D, E, F. It looks like I did 7 everything. 7, which one? 7A? Yeah, 7A. What do I do here? Yeah, distribute negative. What's 5i minus 5i? What's negative 2 minus 2? So it's just distributing a negative and then get your like terms together. What's I squared? Negative 1. What's I cubed? Negative I. Negative I. And what's I to the 4th power? 1, yes. Oh, shit. So yeah, you will have problems like I to the 71st or I to the 89th or I whatever. Whatever I want. Some of you guys understand the idea of when we divide by, we're just taking all the extra revolutions away. What does that mean?
I'm telling her what you're doing.
Oh.
I don't know what you're doing.
Oh, looking around. Yeah.
These are your eyes, you're just looking.
Oh, no. Oh, yes. Which one? 7C. All right, you ready? All right. So, guys, I told you there were a few things we did before that only works with real numbers. One of them is to multiply the insides directly. It doesn't work anymore. Not really. So one thing you could do is you can realize there's a couple of ways. The best way to do it is the way that I did it. What is the square root of negative 81? We can do that now. I can break this up as square root of 81 times square root of negative 1, right? What's square root of 81? What's square root of negative 1? I. What's the square root of negative 4 then? 2i. And what's 9i times 2i? 18i. And what's I squared? Negative 1. Square root of negative times square root of negative is negative. And then square root of 81 times square root of 4 is 18. So you get negative 18. So negatives can't cancel. They don't. Yes.
For the last problem, 9B, do we just write all real numbers, or do we have to show words?
Oh, if you just put all reals, I'm happy. Shouldn't have to do any work. I always used to say the more you know, the less you have to do. It's very true in algebra. Yes?
I forgot. So, when does the test start? Tomorrow?
Right at 9. Yep. So be here. Yes.
For AC, how did you get 4 on one?
Oh, 8C. Okay, you ready? What do I multiply by? Square root of 5 plus 1, right? What's square root of 5 times square root of 5? 5. Minus square root of 5 plus square root of 5, the middle terms cancel. Negative 1 times 1 is negative 1. So that's how you get 4. Yes, ma'am.
Can you do 6C?
6C. So on this one, the first thing I did was I added this sucker over. So when you got two radicals, now if you have one radical, you isolate the radical and then you square both sides. If you got two radicals, you isolate one radical element, kill it, and then you isolate the other radical element, kill it. Right, so it's going to be a couple of squares. Makes sense, a couple of square roots, and you have to square it both sides. So the first thing I did was added this over, and then I squared both sides. Now what that means is, this side will be easy. This side will be a little bit worse. You've got to write it twice. Right? You got to FOIL that sucker out. The big mistake people make is they can say it's 4 plus x minus 1, and they just keep going. No. You lost the whole middle term. Does that make sense? Is that all right? Can't remember how much work I showed because there wasn't much room there. Oh, I showed okay amount of work. Yeah, I would have probably been fine with this. Oh, Jeff. I don't know. I'm averaging pretty good on my practice tests. I mean, is that not enough? What's going on? So then you have to write this twice. 2 times 2 is 4. 2 of these and 2 of these is 4 of these. Square root of x minus 1 times the square root of x minus 1 is? X minus 1. And then you isolate. Now what I did here was, you don't have to introduce fractions. So 4 minus 1 is 3, subtract 3, you get negative 2. Subtract x, you get 2x. I divided by 2. Let me stop there. I divided by 2. I didn't divide by 4 because I didn't want fractions. And I'm the human here. I can control when fractions show up most of the time. So if I leave a 2 there, what do I get when I square both sides now? What do I get when I square this side over here? I get 2 squared is 4. Square root of x minus 1 squared is x minus 1. And then this sucker I just FOIL out. Keep going. Then I got a radical I can get by itself again. I'm sorry. I'm past that point. Now I got all my radicals dead. I can solve for x. And now I got to check my answers. Don't forget to check your answers. You can get ones that don't work with the radicals. When I square both sides of an equation, I'm losing information. That's why there might be more answers at the end than really exist. Because I know as a student, you're like, this is hard enough, and then I do the math all right, and then it gives me a wrong answer. What the shit? Well, it's because part of the process introduces possibilities of more answers than really are there. That's my time. That is my time. It's going to be... Yeah. You can. Wait a minute. So square. Oh, sure. You can square before you divide by 2. You mean square where it says 2x minus 2 equals 4. Then you divide by 16, right? Even then I wouldn't. Yeah. Divide by 4, yeah.